Hello everyone, this video is going to be about the concept of asymptotes and holes. If you're taking Algebra 2 or something like AP Calc and you want to review, this would probably be helpful, but this is going to be mainly for people taking AP Precalc. Honestly, AP Precalc isn't that hard of a class. Like if you're at least decent at math, you can pretty easily pull off a 3. But in my school, it was a self-study class alongside Algebra 2, so a lot of people in my grade didn't really try and thought they would get a 5. But almost all my classmates got a 3 or 4, while I got a 5, and I did really only minimal studying, just like reviewing tricky concepts. And if you do that too, you can easily get a 5 as well. So let's get into talking about asymptotes and holes, because this is a pretty simple concept that a lot of people struggled with, but it's not really that difficult. So what are asymptotes and holes? An asymptote is a line that the graph will get infinitely close to but will never actually touch. This happens because it would result in the graph being divided by 0 at that point, so the graph will never touch that line. The graph can be horizontal, vertical, and slanted. As seen right here, the line is at x equals 3, because if x equals 3, 3 minus 3 is 0, the denominator would be 0, and that's undefined. The hole is a singular point where the graph basically just skips. This happens when there's a factor being cancelled out by the numerator and the denominator, so instead of there being an asymptote, only a single point was removed. Seen right here. Where x equals 2, then 2 minus 2 is 0, but it's also here, so normally you'd just be able to cross these two out. But it's a little bit different, because you can't have it exactly x equals 2, because it's still divided by 0. Holes and asymptotes are pretty similar, but I'm going to focus more on asymptotes, since they're probably going to be tested on more. All you really got to know is that for holes, the numerator and the denominator just cancel out. That's it. Pretty simple. Now, there are different kinds of asymptotes. For the example on the previous page, that was a vertical asymptote. Vertical asymptote is a line that the graph will shoot up or down when it gets near it. It happens when the denominator is 0, and it's definitely the most common and the most simple type of asymptote. Pretty simple, honestly. Now, horizontal asymptotes, I guess, a bit more tricky. A horizontal asymptote is just a line that the graph will level off to the left or the right. It happens when the degree of the numerator is less than or equal to the degree of the denominator. If the degree of the denominator is greater than the degree of the numerator, then the asymptote is always at y equals 0. See this one right here? The denominator is greater than the numerator, so it's just at y equals 0. But if the degrees are equal, then the asymptote is at the leading coefficient of the numerator divided by the leading coefficient of the denominator. So you see right here, the degree for both of these is 2. So it's just leading coefficient 3 divided by leading coefficient, which is just 1. 3 divided by 1 is 3. So you see right here, at y equals 3, that's the horizontal asymptote. Now a slant asymptote is a slanted or diagonal line that the graph will approach. It happens when the degree of the numerator is exactly 1 greater than the degree of the denominator. To find the equation of the slant asymptote, divide the numerator by the denominator and just ignore the remainder. So you see right here, if you want to find the equation, you just simply divide, and I'm going to assume you already know how to do this. If you don't, maybe I can make a video at some point in the future, because it's pretty important to know. I'll just go through it really quickly. Bring down, put 1 here for the coefficient, 3 and a 2. Bring down the 1, and you multiply -4 by 1. By the way, -4 is just, it's positive 4, negative, just the negative version of that. So -4 times 1, that's -4. 3 plus -4 is -1. -4 times -1 is positive 4. And 2 plus 4 is 6. You just ignore the remainder. So you get 1x, which is just x, minus 1. That's the equation of the slant asymptote. Now, let's do a practice question. Which of the following lines are asymptotes of the graph of f of x? So, simply just x minus 4. Well, you can just plug it in the equation, x minus 4 equals 0, and obviously x equals 4 is an asymptote, so that one's pretty easy. Now, we need to see if there's a horizontal or a slant asymptote as well. Well, you have to look at the degree of the numerator and the denominator. The degree of the numerator is 2, and there's no degree here, but that just means it's 1. So that means the numerator is exactly 1 greater than the denominator. So that means it's not a horizontal asymptote, so you can cross out number 2. Now we have to see if y equals 5x plus 20 is right. So all you have to really do is just divide. Bring down the 5, 4 times 5 is 20, 0 plus 20 is 20, and you basically have your answer. You don't really need to do the remainder. So 5x plus 20, 5x plus 20. And your answer is just C. Alright, that's it. It's pretty simple, honestly. A lot of people struggle on it, and just as long as you remember like a few basic things, you're pretty much all set for asymptotes and holes. So, thank you guys for watching.